Hello, I'm JP Fowler.
And I'm Michelle Kretzky.
This is our database system, CSCE413 final project. What we wanted to make was a reasonably realistic database tracking aircraft across the country, across the Midwest specifically, um, coming and going from various airports. We wanted moving aircraft on a realistic map. We wanted airports in their proper locations and states. We wanted the ability to query what state a particular flight is flying over. This is our design overview. It's a standard UML diagram. We've got our entities, aircraft, aircraft type, airport, pilot, and airline. You can see they have all their individual properties. An aircraft has a one-to-many relationship, or rather a many-to-one relationship with the aircraft type, because many aircraft can be of the same make and model. Pilots have a one-to-one relationship with the aircraft, at least in our database. We're just considering individual flights. We're not considering pilots outside of the flights. Pilots are also employed on a many-to-one relationship with their particular airline, as are the aircraft operated by one particular airline. And the airline to airport relationship is a many-to-many, as many airports can operate out of many airports. Here are tables that we made from our diagram. As you can see, there is for the many-to-many relationship between airlines and airports, we had to use a separate table, the operates out of table. We also have the primary keys in bold, as you can see, and foreign keys in italics.
For our data sources, we wanted to use real airlines, airports, and aircrafts. However, the flights and the relationships between them are fictional. We use Google and Wikipedia for data on the airlines and the aircrafts, and a website called Our Airports for the airport locations and their codes. In order to make the relational diagram, we used MATLAB, I2V2C, and a JPEG map of the Midwest for the state constraint relations. And in order to go from a vector representation of a polygon to a constraint relation, we took the airports, which happened to be square in shape. We took the points and changed those into constraints. So x is greater than 681 and less than 691, and so on and so forth. And here is an example of our points of a polygon on a JPEG image to the constraint representation. And as you can see, potentially Nebraska has some points already drawn on it, and it is about to get another point when this screenshot was taken. For our demo, we have a visualization of a geographical or spatial object, and here is our map. We have the airports, which are in yellow, and the aircrafts, which are dark blue, and then we have an animation of moving object, which I'll play, and those are our aircrafts flying between the different airports. And we also have 5 SQL queries, with 3 of them using constraint relations. To start off, we have our collisions, or let's see. Okay, we have our planes over Iowa at 30, and this is when 300. And this is when T equals 300. And then those are the different planes that are over Iowa at that time. And then we have another basic query, which is the collisions. And this is also with a constraint relation. And we have the call signs for the planes that collide. And this is the query for it. And then if we run that, then you can see that there are 2 different collisions that occur between these 2 planes and then these 2 planes. 2 of those planes collide at right underneath the Wisconsin border, and 2 of them collide at the O'Hare Airport, and that is because every single plane takes off at the exact same time, and so there's 2 planes leaving the O'Hare Airport, and therefore they're going to collide. And then for our last query using constraint relations, see, we have a sets query, and this is going to be the planes passing over Nebraska or South Dakota. And this is the query here with a union between them. And that yields these results. And so these are the 6 planes that at some point in time do pass over Nebraska or South Dakota. And then for our other 2 queries, we have an aggregation. And this is going to be all of the different airlines that or how many different airlines operate at each airport. And so if we look at the results of this one, then you can see that most of the airports listed here have 3 airlines operating out of them. Some do have 1, some have 4, and then O'Hare has 8 right here. And lastly, we have a nested query, and this is going to be the fastest pilot and plane. And if we look at the results of this one, you can see that Frank Abagnale is the fastest pilot because he is the one riding the Boeing 707. And so here you have our visualization of a geographical or spatial object, which is our map, the animation of our moving objects with the airplanes, and then the 5 SQL queries with at least 3 of them being constrained. And that is our demo. And here are our conclusions in future work.
Yes. So what we didn't get to implement here was fuel range. We could do a capacity, like a fuel capacity that each plane had. And one way was we could have like a radius around the plane that could shrink as the plane flew, because it's the amount of distance it can travel on remaining fuel. And that would be the animation which shows moving objects with a changing shape, because that circle would get smaller. And we could also use that buffer feature on MLPQ to detect that as well. And we could decide what airport, let's say there's like a blizzard at O'Hare, we could reroute flights based on how much fuel they had remaining. We could also implement altitude, so like those 2 planes that cross over each other, we're just using X and Y. Those planes could have passed above and below each other just fine and not collide. And that's, again, avoiding mid-air collisions. We could also implement a system to detect those mid-air collisions and also reroute them in order not to have collisions. Another thing we didn't take into consideration with our implementation was the curvature of the Earth. We just used basic X and Y kind of Mercator projection, which, of course, the further north you go, lines of longitude get closer together. So the distances are a little bit just basic for our implementation. Another thing, we just did the Midwest. Future work could include the entire US or even international flights. And we also just made up some flight data using some names of classmates, whereas we could use actual real-world flight data that we could get.
Thank you so much for watching our presentation and for giving us such a great opportunity to learn about databases.
Hope you enjoyed it.
Thank you.